Welcome to this class on methods of economic analysis. This class is about the value added. This is part 2. It's the last class of value added before looking at the last topics of this course in the next class. Today we have the problem of discounting the value added, because when we analyze a project, we know that this project will generate value added for several years in a long time horizon. So here the problem is to discount all the value added generated in different moments by the project and get a synthetic measure of the present value of the value added, as we already did in financial analysis and as we already explained also for the economic cost benefit analysis. Accordingly, we'll leave this outline today. First, we'll look at the net present value of value added. So we'll look at how we should discount the value added generated by a project during its entire life. Then we'll look more specifically at the methods of calculation of the net present value of value added. And then we'll conclude this class by looking at the multiple criteria approach adopted by UNIDO. We'll look at in particular which tests UNIDO is applying in additional to value added calculation that are based on the value added, but provide some more complete indication about the value created by a project. So let's start from the net present value of value added. In order to calculate the net present value of value added, we have to follow the following steps. First of all, we have to calculate the value added for each project period. Then we have to calculate the discount factor and apply it to value added for each project period. And then we have to calculate the present value aggregated for all the periods. So in other words, we are following the same logical procedure that we already apply for the calculation of the net present value of cash flows in financial analysis, of the calculation of the present value of economic costs and benefits in the economic cost benefit analysis. Because the first steps requires that we calculate for each year of the life of the project the value added. And so we know that the project is a long-term life, last several years. So for each of the years of the life of the project, we should determine the expected contribution of the project to value added. Once that we have calculated all the value added for the project, we should calculate the discount factor. And the discount factor is to be applied to each of the value added that have been defined for each period of the life of the project. And this is a critical issue, because as we already discussed it for the economic cost benefit analysis, when we have a national interest in the project, and so we have a national perspective with different goals, we cannot adopt the cost of capital that we used for discounting the cash flows in the financial analysis in the perspective of the investors. Because I remind you that in that case we used a cost of capital that was based on the expectations of return of the different investors that put money into the project. Here, clearly we have not only a problem of investment and prior returns, but we have a problem of national goals, and so we should work to determine a specific discount rate that is consistent with the national goals that we are pushing. And finally, once that we have calculated all the value added, and that we have discounted each of the value added to time zero, so to the present moment, these value added are comparable, and therefore I can just add them, and in this way determine the aggregated present value for all the periods, and this will be the net present value of value added. So as you can understand from this slide, the most critical aspect in determining the net present value of value added is the calculation of the discount rate that will be at the basis of the discount factor. And therefore now we'll analyze in detail these topics. So at this point we can look at the methods of calculation, and in particular in the methods of calculation we refer to the social discount rate. Because method calculation basically are calculation of value added that we already discussed in the previous class, so this is already been explained. So now the problem is how I discount this cash flow. And so for methods calculation, the most relevant aspect now is the determination of what we define as social discount rate. So in this slide we have a general formulation for the calculation of the social rate of discount. We calculate the social rate of discount multiplying RW, where RW is the actual interest rate in the world market, times a factor that is defined as 1 minus PD, where PD is the premium for domestic projects. This expression can also be developed. So if we develop this expression, we got this new expression here, and so we know that the social rate of discount is equal to RW minus PD times RW again. So what is the logic here? The logic here is that you could use as basis to determine the social discount rate the international interest rate. So international interest rate that is generally available in world financial markets. But as a government, you may want to incentive the investment in your country. So you want to encourage domestic projects. And so in discount, and you want to encourage investment. So in order to discount less future value added and get a higher net present value added, you can decide to reduce this interest rate by recognizing a premium to the project. This premium reflects the importance of the project for the achievement of national goals. And this premium can be calculated in several ways. So this is a general expression. The premium can be formulated and calculating in very different ways depending on specific situations and specific objectives of the national government. But typically depends on the experience that the government has with this kind of analysis and should account for a series of macroeconomic variables such as the expected rate of growth of the national economy, expected long-term returns of domestic project, expecting long-term rate of inflation, and so on. So again, this is general formulation for the calculation of the social discount rate, but you could interpret the premium for domestic project that is clearly the relevant topic here in different ways, because typically the interest rate in the world market is known. So what really depends on subjectivity and on the objectives of the decision maker is a premium for domestic project. Here there are no clear rules, but there is the idea that the more you want to incentive investment in domestic project, the higher the premium, the lower the discount rate. So as a consequence, the higher the expected net present value of the value added generated by this project. So the idea is that by increasing this premium, you make all projects more attractive. So on average, you should have a higher amount of money invested in domestic projects. So say that at this point, given the definition that we know, we can at this point calculate the present value of the net domestic value added, or eventually, if we want, as we'll see in the next slide, of net national value added. That is what we use most in the analysis. So as you can see here, first of all, you can determine for each period J the net domestic value added. So J refers to the period. We have several periods. There, in particular, we have n periods in the life of the project. So here, the first line is about the calculation of the net domestic value added for each of the periods in the life of the project. And the net domestic value added is calculated in a consistent way with what we said in the previous class about the definition of the different levels of value added, in particular about the net domestic value added. In particular, here the net domestic value added at time j can be calculated in two alternative ways depending on whether you are adopting a static or dynamic view. So in case you are adopting a dynamic view, that is the first expression, you have the level of output of the project at time j minus the total expenditure for material inputs at time j and investment made at time j. So in a dynamic view, we are looking not at the depreciation that we have for that particular period, but if we are interested in the moment when the investment occurs, so in the moment when you pay for the investment, here you are subtracting the whole investment and not the depreciation from the output in order to determine the net domestic value added. Instead, here you have the calculation net domestic value added at time j, but this time using a static view, because here you are subtracting the not the investment, the depreciation. So here in the static view, the net domestic value added at time j is equal to the value of the output produced by the project at time j, that is OJ, minus the sum of the intermediate materials at time j and the sum of depreciation time j. So let's say that the static view is more useful when you want to understand what is the net value added created in a given moment, so at a given period of the life of the project. But then if you want to aggregate this value into a net present value, it's more correct to refer to investment and not to depreciation. So say that once that I have calculated the net domestic value added for each of the period of the project, I can determine the aggregated net domestic value added. The most simple way to do that is just to sum up for n years all the net domestic value added that I have calculated for each period j, without accounting for the discount factor. So and in this case, I'm not calculating a present value. I'm just adding all the flows of net value added, net domestic value added that will be generated by the project in its life. So I have what can be defined a nominal value of net domestic value added, but this nominal value does not account for the timing of the value added. So consider the same way projects where the value added have been generated uniformly during the life of the project, and project where instead the value added is mainly created at the end of the life of the project. And we know that this time is a value, and this is one of the first lessons that we have learned in this course. This method could be highly imprecise because the timing of the value added could be an important issue for the national government and for the decision maker. And so this would require that before adding all the net domestic value added generated by a project, it will be more appropriate to discount them, so to report them to year zero and to make them comparable in this way. And this is exactly what is done here in the last line of this slide. So here we have net present value of net domestic value added. That is calculated as a sum of all the net domestic value added generated in each period j for the n years of the life of the project. But this time, each net domestic value added j is discounted because it's multiplied by the relative discount factor at year of j. So the discount factor at year of j will depend not only on the timing, that is year of j, but will also depend on the discount rate that we'll use, and so depend on the social discount rate that we have defined in the previous slide. So once that you have defined the discount rate as in the previous slide, and you determine the social discount rate, you can easily calculate the discount factor as we explained when we're talking about the time value of money. The logic and the procedure is exactly the same, so we are just discounting future values. And so in this way we get a present value, net domestic value added, that in theory is a more precise measure of the total net domestic value added generated by a project, because accounts for the different timing of the net domestic value added generated by a project. And so these methods allows the decision maker to distinguish projects that generate the same nominal value added, but that have a very different time profiles. So you could have two projects with the same nominal value added, but in one case the value added concentrated at the first part of the life of the project. In second case, the value added could be concentrated in the second part of the life of the project. The nominal value added is the same, but in terms of present value of net domestic value added, clearly the two projects will be very different. And calculating the present value allows the decision maker to discern the different time patterns of the project independently of the nominal value added that they generate during their life. So one of the critical aspects of this process, however, as you can understand, is the determination of the social discount rate. So what I mean here is that in theory, the procedure of discounting net domestic value added is more correct from a theoretical point of view, and this is something that we already discussed. But what we already know is also that the present value added is strongly affected by the choice of discount rate. So in the case of the financial flows, the cost of capital had quite standard parameters to be estimated. Now, as we understood, the social discount rate is based on the subjective estimation of a premium. And this can represent a problem because different opinions about the premium that I should recognize to local investment could impact in a significant way on the present value of net domestic value added, because given the flows of net domestic value added, given the timing of these flows, the net present value will be strongly affected by the discount rate that I use to determine the discount factor. And so a lower or higher premium that I choose to calculate the social discount rate is important and can affect the project in an important way. So the present value of net domestic value added presents this limitation. Another aspect that I wanted to stress is that the choice of the social discount rate that is used here in this line depends a lot on the numerator that you choose, in the sense that when we analyze the economic cost benefit analysis and we look at the present value of the net benefit of a project, we used the consumption rate of interest. So now, and this is because the numerator of the ECBA analysis is mainly represented by domestic consumption, so it made sense to use the consumption rate of interest as a discount rate. In the case of value added, the social discount rate, as we saw, could be that if the numerator of the valuation is represented by consumption, but starts instead from the interest rate on the financial markets, as we saw in the previous slide, if the numerator is income and not consumption, so it's more correct to use that version of the social discount rate. And clearly this choice can again impact on the present value of net domestic value added that I have here in this last line. So just as a final message here, the calculation of a present rather than a nominal value of net domestic value added is more correct from a theoretical point of view, but at the same time is involving a high degree of subjectivity in the estimation of the discount rate. So the decision maker should be aware that different choices about the discount rate, whether I'm choosing a social discount rate or whether I'm choosing a consumption rate of interest, and the eventual determination of the premium for domestic project can strongly affect the final result of the valuation. The same type of consideration apply to the calculation of net national value added. We saw in the previous class that there is a very important difference between net domestic value added and net national value added, because net domestic value added reflected all the value added generated in the country, independently from the fact that part of this value added was repatriated in the home countries of the foreign subjects that participated into the projects. Instead, the net national value added focuses on that part of the value added that is created in the country but also stays in the countries, and therefore is net of repatriate payments made by foreign subjects. And this is the typical parameter that is chosen for the valuation of a project, because what typically matters for national decision makers is not only what you are able to generate in the project in terms of domestic value added, but also what remains in the country as a basis for future consumptions and savings. So in the end, this is the more appropriate basis for the evaluation of a project in the perspective of national governments. So in these two expressions, as we'll see in a moment, you find the calculation of the nominal net national value added of a project and the present value of the net national value added of a project. But the variable, the expression that you find here in the parentheses is equal for the two expressions, and is basically the net national value added that has been calculated for each period J of the n periods of the life of the project. And you can see that the net national value added, consistently with the definition that we provided in the previous class, is calculated as the difference between the output at time J, here indicated as OJ, and the sum of three variables that are material inputs, as in the previous case, investment, as in the previous case. Here we are adopting a dynamic view, so we are focusing on investment and not on depreciation, also because for discounting this is the most appropriate way to proceed. So if we stop here after ij, so after the investment made in time j, we will have again the net domestic value added. But here we are adding to these variables, and so we are subtracting from oj also the repatriated payments that, as I was saying at time j, that I was saying are the payments made by foreign subjects to their home countries. So the difference between the output generated by the project at time j and material inputs, investment, and repatriated payments is the measure of the net national value added created at time j. Now, in the first expression, we are just adding up all the net national value added generated by a project without accounting for time value. So as you can see, there is no discounting. And so we have again a nominal value of the net national value added created by the project. That again has the limitation of not accounting for the time pattern of net national value added, so does not distinguish between projects having the same aggregated net national value added but with different time patterns. Instead, in the second expression, we are multiplying for each period j the relative net national value added times the discount factor at time j. As we multiply each net national value added for the relative discount factor, we are calculating for each of these net national value added its present value. So we are summing up present values. So we are summing up values that are consistent and coherent from a timing perspective. And in this way, we are getting net present value of the net national value added, that, as we discussed for the net domestic value added, is the advantage of considering in a more appropriate way the timing of the net national value added, and therefore is able to discriminate projects based not only on the value-added creation, but also on the timing of this value-added creation. Again, here we had the same problem that we had before with net domestic value-added, in the sense that if we want to calculate the present value of the net national value-added, we have to determine the discount factor for each period j, and in order to determine the discount factor for each period j, we need a discount rate. And so here, typically, you apply the social discount rate that we had defined a few minutes ago. Even though you could make different choices, as we were discussing before, depending on the numerator that you're taking as a basis for the valuation. And even though you take the general formulation on the social discount rate, you can make different choices about the premium for domestic projects. So again, as in the previous case, given your estimation, the net national value added for each period of the life of the project, you could have different results depending on the assumption that you will make at the social discount rate. And so this is an aspect of which, as a decision maker, you should be aware, because the different assumption about the social discount rate can make really a big impact on the valuation of the project. So now we conclude this class by presenting and by shortly introducing the multiple criteria you need approach. So the multiple criteria of you need approach is based on different criteria that are applied simultaneously to the evaluation of a project. And here you have, in particular, 5 criteria that are reported here. The net national value added, that is what we already discussed 1 minute ago, so that's exactly what is done. And so net national value added is a component of the multiple criteria approach. Then we have, you have 2 tests that we'll discuss in greater detail before closing this class, that are the absolute efficiency test and the relative efficiency tests. The absolute efficiency test is the objective to check whether the wages are lower than the value added. And this is important because if wages are higher than value added, the project is generating a negative social surplus that can create problems for the project. And you have a relative efficiency test that basically compares the value added generation to the value of the resources that are employed by the project. So we'll give a more detailed look to this test. And then there are 2 other issues that are considered here. One is income distribution, and the other is non-quantitative impacts. So these particular aspects will be discussed in the last class, but we can provide some hints here. So income, as we have discussed several times at this point, the national government could be concerned not only about the creation of undifferentiated income, but could be also concerned about how this income is distributed across contemporary or social groups or different generations. And so you could weight different value added created for different social groups in different way, or you could calculate an index that allows you to determine how the value added is distributed to different social groups. So you could see, for example, what is the weight of each social group in the total value added created. And finally, you could have non-quantitative impacts, so impacts that are not immediately measurable from a monetary point of view, but you know that are important for the society and the economy as a whole. And so you could have what are typically defined as non-monetary externalities or non-quantifiable externalities that will be specifically analyzed in next class, but that in some cases could be relevant as well for the evaluation of a project. And so even though you are not able to include them in monetary terms within your evaluation, you should consider them in a separate moment of the decision-making process. Let's look now at the 2 tests I was mentioning before. Let's start from the absolute efficiency test. Then, before closing this class, we'll look at relative efficiency test. The absolute efficiency test is represented in these slides. Can be formulated in two ways. The first one is a static version, where you are comparing the net national value added with wages paid by a project in a given moment in time, whereas the second version is the dynamic version of the same test, where you are comparing value added of net national value added and of wages over time. So here in the static absolute efficiency test, for each period or for a given period you are interested in the life of the project, you are comparing the net national value added with the wages that are paid by the project in that year. So what are you interested in? What is this test about? This test is interested in establishing whether the net national value added in a given period is higher than the wages that are paid in that year. Because if net national value added is higher than the wages, this means that the project is also generating a social surplus. And a social surplus is important for future consumption and savings, and therefore for future investments. If instead the net national value added is lower than the wages that are paid in that same period, this means that you have a social surplus that is negative. It's because the net national value added is given by the sum of wages and surplus. If the wages are higher than net national value added, this means that the social surplus is negative. Clearly, having a project with a negative with a negative social surplus is a problem, because this means that it's true that the project is increasing net national value added by generating wages, but at the same time it's destroying wealth. It is implying losses for other individuals, in particular shareholders or creditors or whoever, in the sense that in order to balance the higher wage, there will be a negative loss for these subjects. And this clearly reduces the basis of consumption and investment, in particular investment, coming from other incomes so different from wages. So it's important anyhow that even though the net national value added of a project is positive, it's higher than wages, because this signals that the social surplus is positive, and clearly the government is not only interested in having projects with high wages, but as I was discussing in the previous class, is also interested that the project is generating a social surplus available then for consumption and savings. So this is also the final objective. The same test can be repeated in a dynamic way, where you're not only comparing the net national value added with wages in a specific year, but you are comparing the present value of net national value added with the present value of wages. So the comparison of present values allows us to extend the efficiency test from just one single period to the whole life of the project. So this is why the test is defined as dynamic. So it can happen that in a given year the net national value added is lower than salaries and wages, but the important thing here in the dynamic test is that overall, so for the whole life of the project, once that we discounted net national value added and salaries, the present value of the first is not lower than the present value of the second. So in this way we are able to have a synthetic test on the whole life of the project and all the net national value added and all the salaries that are paid by the project. So this gives us a more reliable test, because does not refer to just one period in time, but refers to the project as a whole. So the important here, the important message is that the project not only is to create net national value added, but is also to create a positive social surplus. It can be, the social surplus can be negative in a particular year, but on the whole life of the project, there is to be a positive social surplus in terms of present value. This is what I see from the dynamic absolute efficiency test. The second test that is typically applied by UNIDO to value the analysis is the relative efficiency test of use of scarce resource. So the test is illustrated in this slide, and you see that it's based on a ratio that is here between the present value of value added, that is what we have defined so far. It could be different definitions of value added, but as we have seen in the previous slides, typically you prefer to use for this purpose net national value added, so the value added net of also the repatriated payments, and the present value of scarce resources that are used by the project. So in other words, you want an index of efficiency that says how much value added you are generating for each unit of value of scarce resources that are employed in this project. So for example, you could want to decide among different projects. Both projects have a positive net national value added, so you don't know which one to choose. At this point, you have to use for both projects a scarce resource. You want to understand what is the project that is creating more value for that scarce resource. And this is exactly what the test is doing. The test is doing is saying to you how much value added, in particular net national value added, the project is generating for each euro of present value scarce resources indicated here as P, S, R. The important aspect here is that in performing this test, you should carefully measure the value of scarce resources, because one of the most important things that we have said about scarce resources in the previous classes is that when there is a scarcity of resource, the market price of that resource could not reflect the true economic value of that resource for the economic system. And we saw that we typically solve this price distortion using accounting prices rather than market prices. So the denominator of this expression, that PSR, that is the present value of scarce resources, should be measured on accounting values of scarce resources rather than market value of scarce resources. In these conditions where there are strong distortion of market prices, where one of the conditions when this happens is when the resource is highly scarce, and so its economic value can differ from its market price. In other words, the procedure here is I calculate the net national value added for each year. I then set a discount rate, possibly in the form of social discount rate. Calculate the present value of the net national value added so that I know if the project is generating overall a positive or negative net national value added. Let's assume that the value is positive before deciding to accept this project. In the multiple criteria approach, I submit the result to two tests. One was the absolute efficiency test, where I tested whether the net national value added was higher than wages. So in other words, I was testing if the project had or not a negative surplus. And the second test is to understand what is the creation of value added for scarce resources, and this is important when I have to decide between different projects that employ scarce resources. And finally, as we'll see, I can add other indicators and consideration before making a decision. Some of them are related to income distribution. This is something that we already discussed, but we'll discuss in more detail in next class. And moreover, most importantly, there could be some effects related to non-quantifiable or non-monetary externalities that should be then analyzed separately. And this is something that will be at the core of next class. So at this point, this class is ended. I thank you for your attention. And I remind you, as usual, that if you should need any additional material, you can refer to the course website. Thank you. Welcome to this class on methods of economic analysis, other issues. So this is the last class of this course where we'll analyze some remaining issues about the economic analysis of projects, and where we look in particular at other supplementary indicators we can use along with the economic cost-benefit analysis and the value-added analysis. And when we'll have a final focus on externalities, in particular on the potential quantification of non-market externalities. So accordingly, the outline of this class is organized as follows. First of all, we'll talk about supplementary indicators that we can use in addition to the methods that we already analyzed. Then we'll talk in general about the appraisal of externalities. And then we'll conclude the class with the focus on non-market externalities. So let's start from supplementary indicators. So supplementary indicators reflect fundamental development objectives that the national government can have in a given policy, and so can be relevant for the final appraisal, evaluation, and decisions about an important project. The typical supplementary indicators that are considered in the economic analysis of a project are the following: the employment effect, the distribution effect, the net foreign exchange effect, and international competitiveness. So now these indicators could be analyzed separately, so each of these indicators could be calculated or measured in some way and considered in a separate way within the broader context of the economic analysis of the project. Or they could be weighted to arrive at the synthetic indicators that expresses a final judgment about all of these effects. So now let's give a more specific look to each of these indicators and to the possible methods of calculation of a measure of the indicator. Let's start from the employment effect. So employment effect mainly refers to the jobs created for unit of investment. So this could be obtained by dividing the number of jobs that the project is expected to create by the total amount of investment required by this project. So this is saying to us basically how many jobs we create for any unit of currency, domestic currency spent in investment for this project. So this is very simple indicators and measure the potential job creation of a project. Then we have the distribution effect. So here we have always the same issue that is important. The analysis on the value added that we have seen in the previous classes was about the contribution of the project to the undifferentiated income, that is income generated by all the social groups, no matter who is benefiting more from them and no matter about the equity objectives. But distribution effect will be one of the main objects of the national plan we are considering, so the project could be relevant also in terms of distribution effect. So in case we have calculated the contribution of a project to the undifferentiated income, we could ask which social group are benefiting more from the project, and therefore we could analyze and calculate ratios for different groups. In particular, if we work on value added, the relevant groups are wage earners, so employees and workers, rent or interest earners, and profit earners, and the government. So these are the subjects that benefits from wages and social surplus. And what we could do, we could calculate ratios of the value added accruing to each of these social groups divided by the total value added created by the project. So this will give us an additional information about how the value added generated by a project is distributed among social groups. And so this could allow us to verify whether the distribution of the value added among social groups is consistent with national objectives. So for example, it could happen that you want to increase as a national goal consumption of wage earners, so you're mainly interested in the fact that the employees and workers get the highest part of the value added created. So this could be easily determined by the calculation of a ratio between the value added accruing to wage earners and the total value added generated by a project. But you also may have an opposite objective, that is to have a higher social surplus in order to increase the savings. In this case, you would expect a higher ratio of value added accruing to profit or interest earners as compared to other social groups. So this effect is mainly related to distribution and not creation of value added. Then you have the net foreign exchange effect. This is an effect that is related to the generation of a flow of foreign exchange. So you're basically interested in the difference between the positive flows of foreign exchange and the negative flows of foreign exchange. And this could be